I'm Tony Kay. I work out of Bend, Oregon, which is about 3 hours sort of southeast of here. I'm going to be talking to you about testing today, and I appreciate that we're all coming back from lunch and might be a little muddy-headed, and you know, I hope I say enough interesting and entertaining to keep you awake. And I promise that, you know, if you get through this testing session, there will be cake. So I love this quote. This is one of my favorite quotes of Rich Hickey. It's one of the first talks I watched when I joined the Clojure community. It was Simple Made Easy, and he makes this joke with guardrails. You know, we say I can make change because I have tests. Who does that? Who drives their car around banging against the guardrails? And he was really making a comment about how the test-driven community talks so much about testing driving your design. And that really strikes a chord with me, that is a thing we kind of promote when we talk about testing, and it is a little misguided. So I really liked that, but then, you know, as you think through it a little more, we do make guardrails, and we make guardrails for good reasons. You know, when you look at this picture, how fast is the traffic moving on this road? It's probably not moving very fast, right? The cost of making a mistake is relatively high. There's little protection, and there's a lot going on, right? So this idea that we never want tests, obviously, if you're here, I hope that you agree with me. There are times when we want guardrails. But we probably don't want to build our guardrails like that. And this is often what we do, right? This is why a lot of us feel a lot of pain about testing, is we build tests that essentially just, we trip over them constantly. They cause us a lot of hassle. They give us kind of low benefit. And, you know, but at the same time, we shouldn't really judge the benefit of the activity from the results of our worst practitioners. You know, so when I hear, I don't value writing tests, you know, it was hard, things went wrong, I just ended up deleting them all. I get it done without tests. Well, okay, that's a valid experience. I've had that experience. I have deleted untold numbers of tests. I have made tons and tons of mistakes when testing, and so I have a lot of compassion for the, it didn't work well for me, so I stopped doing it. However, why do we expect anything but bad results from something we're just learning? I mean, after all, define testing. And I would challenge you to try this exercise. Screen record yourself. And do it long enough that you forget you're doing it. So go for a couple of hours and then go back and look what you were doing. How much time did you end up fiddling with it in the REPL? How much time did you end up clicking through a UI? How much time did you end up seeding data into a database so you could try out the thing? Right? We spend a lot of time testing and we throw it away. And, you know, do you really get twice as much done when you don't write tests, right? We essentially do bad accounting and then say tests are just more expensive. Excuse me. So one thing that was really, when I proposed this talk, and it got accepted, my first reaction was, oh crap. Now I've got to write a talk that people don't go, oh, that sucked. You can almost smell the psychosphere around testing, especially in the Clojure community. It's a really polarized issue. And I've found that people problems really are very often the biggest problems. You've got you know, this you're the expert, figure it out attitude from whatever business you work for. And they might be asking you questions like, why are you writing tests? That's not getting my feature done. Right? You have this hostile thing. You might be hearing that from other developers as well that have had bad experiences. There's a lot of just culture around this, and failure and problems. And I've, you know, in my career, I calculated this out when I was writing this slide. I've met about 3% of the engineers I've met were any good at testing. And had actually practiced it long enough to get good at testing. The rest of them were just like, yeah, I tried it for a day or two and blah, don't want to do it. So we don't teach this. It's not something I think everybody I've ever asked, and I would love it. How many people had a great experience learning about testing in college? 1, 2, 3. Ouch, right? This is really at the core of the problem, is we neither give ourselves permission to learn it well, nor are we taught it. So that's where I'm trying to get here with this talk, is I'm trying to show you where you can get demonstrated value. And for me, the best value I get is what I've proposed to talk to you about, and that's simplicity. I don't mean test simplicity like this, right? When I look at this test, you get it. You know what this test is for. It's accurate. It's self-contained. It's relatively well labeled. You might have mixed feelings when you see the test, but you can't argue that this isn't a good test, right? However, most of us, when we first get into testing, we're used to playing with the REPL. We're used to clicking through the UI. And so when we write our tests, we do this. Ooh, can't wait to throw a browser stack at this, right? We write this big convoluted thing that requires a ton of setup and really tries to test it the way we think it ought to be tested, because it's kind of our habit of testing the whole wad. The whole complicated thing. And so our tests very often look like this big complicated mechanism. And you're not going to get wide coverage easily or affordably with this. But at the same time, if you're writing software for an airliner or a heart monitor, you might be stuck with this, right? You might really need to test a system that costs a lot to test. And so that's not what I'm talking about here. If you're in that space, I don't work in that space. I build web apps. So I am kind of trying to narrow the focus to there are cases when this is what you need to do, and it's a bit harder to do, it's more expensive to do. It gives you, a more predictable, not more predictable, a more trustable result on a very specific hard problem. So I kind of want to narrow my problem focus. So when I teach people to test, I first start with an analogy, and I love the onion analogy, right? If you're writing clean software, what you're doing is you're building abstractions, and you're sort of layering those abstractions. I've got some little thing that I build, and then I build a layer above that. And as I get to the third layer, I don't talk about that low layer anymore. I'm now in a higher level of abstraction, et cetera. And I often, in my analogy, I say, the side effecting, one of the things that I really love about Haskell is it tries to separate the side effecting stuff from the pure stuff in a very strict sort of way. And we can get benefit of that. We don't necessarily need a type system to enforce that for us. But I do like the idea that when we go to interact with a database, there's a lot of complexity there. There's schema, there's networking connections, there's all this stuff. Isolating ourselves from that as much as possible and getting as much code into pure functions is great, right? Pure functions are a little easier to test. But even when well designed, a software system has combinatorial complexity. Each of these layers has behaviors, and we've stacked them all up, and that's an exponential growth problem, right? 10 behaviors here, times 20 there, times 30 there, times 10 here, times, right? We can't write all those tests. And many, we can, sorry. So when we do this, most people are good at testing the edges. We're good at testing the layers where things are isolated, things are pure. But then this happens, right? We pick up the onion and we just take a big bite out of it. We're like the Tootsie Pop owl for onions, right? The older people are laughing at that joke. So instead, we say, let's try isolating these layers. Let's deep fry those suckers. Right? Let's make them tasty. Right? We separate them out. We can get kind of high confidence that some of these pieces are in fact tasty. And we can gain back some of the speed and simplicity of moving through these things. But it's not magic. So ultimately what I'm trying to talk about with this is the trade-offs between unit testing and something else. Right? So this is kind of sort of a summary of these things. If I involve less code and or less behaviors, well, the grand total of those, if I add those together, that's a linear problem. I still might have a lot of tests, but I can get high confidence in localized behavior. I can say that thing does what it's supposed to do. And I'm really confident that all of the things it's supposed to do are right. But I have questionable confidence in the global behavior. But I get a low cost per behavior on kind of the left side of this graph. On the right side, I've got more code involved. My total behaviors is an exponential problem. I'm probably not going to cover very many of them, right? I've got kind of a high cost per behavior. But I have high confidence in those few properties in the large and kind of lower confidence in the smaller ones. I'm going to talk about some examples here in a minute, but this is kind of the general thing I've got in my head. But even without combinatorial complexity, it's still not necessarily easy. Take sine. We know this function. It's pure. Give it an input, gives me an output. We've understood it for hundreds of years. This is a Taylor expansion, that the more terms we add in, it very rapidly converges, we get a value. When you look at the fast sine implementation, it's about 800 lines of C, and this is the implementation that's in most Linux standard C libraries. Do we just trust that this is working? We wrote this 800 lines and maybe did a quadratic curve approximation, and now, well, we just know it's right because math. Well, it's 800 lines of C using base 2 approximation of numbers that I'm going to use to calculate structural stresses in steel. I think I want tests for this, right? But how would you test this? How would you test sine? Hopefully you wouldn't just press the release button and wait for complaints to roll in, right? This is often what we do, and all right, I think in this case probably not the good thing. And very often this is what you do, right? You write some test case and you say, all right, expected should be the sine of an angle, let's give some examples. Good enough, right? I run clojure, it tells me 100% covered. I've covered all the lines of code. Am I done? Is it right? Well, why did you choose those angles? Is that a good enough sequence of samples? Okay, generative testing, right? This is the thing. We want generative testing for this. What does that look like? Well, it looks like behaviors and properties, right? You still have to say what the thing's supposed to do. That's the hard part, right? So you have to think about this. What does it do for small angles? What does it do for large angles? If I throw a double that has a really large value at sine, well, all of the small digits in that, right, if it's something to the e to the 300th or something, am I going to get an accurate result from sine? I should probably specify how it should behave there. I should specify what the range is. And you know, when I think through this, the only way I know to test this is either to make a really large table of stuff I know, or write a slow implementation that uses that Taylor expansion, right, to give me as accurate a result as I want, that I know is slow, and then compare that to my fast results with some, you know, epsilon that says it's got to be within this range. But notice what I just did there. I said, in order to test this, I have to write another version. And this is very often what you do in generative testing. You know, it's one of the techniques. So let's talk about generative testing for a minute and what the pros and cons are here. So the one I'm just talking about here is the third one down, trusted implementation. I can have, maybe I get one for free. Reed Draper's talk at Clojure West a few years ago talked about a case of this where was actually a pre-existing trusted implementation you could go against. But I could write something where I'm pretty sure I can get, in this case, as much accuracy as I want, and then write a property that says you've got to be within 1% of this for this range. Fine, generative testing done. But I did have to write twice as much code in that case, and the tests. It's also good for checking invariance. If you've got, you know, a system where something's going wrong, my file is becoming corrupt, it's really good if you can model, hey, throw a bunch of operations at it, and the property is the file is never corrupt. Great. It works really well for finding those. It gives you a minimized case. You can debug it. It's good for, in this case, kind of debugging a problem with a system. It's also good for reversible operations, marshalling, things where you want to throw arbitrary data structures at it, finding arbitrary problems, and stateful systems. And you really should watch these talks. This is a tool. It's a great tool. It's not a panacea. It doesn't solve all your problems. So learn it, but getting good at other approaches is still important. So I have a very short list of rules. I don't like giving people a whole big complicated mess of stuff to try to remember and do. This is a task that's hard. It's something that does require you to turn on your brain and think through the problems. But there are some ways of simplifying it, and that's the whole point. So the first one is be critical about what and how you test, and know your tools. If you don't have that, right, the more tools you have in your toolbox, the better you're going to be at it. And ultimately, what I'm looking for, unless, again, I'm writing something that's a heart monitor or something, is low cost, high benefit. I'm going to choose a layer of abstraction. I'm really going to stress the unit testing, but I'm really going to try to get to the unit. And that's the part that I see most people struggling with and not doing well. They think they're unit testing because they're using a unit testing library, but they're not actually unit testing. They're grabbing these big chunks and biting the onion. So don't clump things. Try to really separate out the specific things you're trying to show and be really clear about those. And that brings you specificity. You really want clear language to target the interesting things. And this is a little troublesome in a male-dominated field because it means you have to use your words. We're not necessarily always good at that. Lack of descriptive, accurate, detailed language around tests really makes it hard. I've got a head scratch. I go and look at a test and it's like, what were they trying to prove here? The test is failing, but now I've got to go reconstruct the logic of what you were doing when you wrote the test. That's a nightmare. Right? Don't do that to yourself or others, because you're going to be your own worst enemy when you come back and look at your failing test and you don't understand it. Or you look at your test and it says one thing, but it's actually proving another. You don't want these things to be obscure. You don't want to make people rediscover things. And so my general rule is name the thing under test and then actually type out an English sentence about it, right? There's in ClojureScript test, there's a testing clause you can use to put that sentence in your output of the test. This is what's wrong. I feel so strongly about these two things, being able to isolate things really well and being able to describe them really well, that we actually maintain an open source library called Untangled Spec. And it's really just thin wrappers around Clojure and ClojureScript test. Everything in those libraries works in it. And it just adds some extra reporting support and some helpers for isolating. And the only reason I'm even mentioning it is because I'm going to show you some examples here in a minute that use it, and you might want to know what it is that I'm using there. So again, the most important features, isolation and description. And feel free, I'm actually manning the Navis table out here in the main area. So feel free to come by and talk about any of this stuff. I'd be glad to show you more details. So let's look at some examples. The first one is a React-based example. We do full stack ClojureScript development. And there's this thing you can do, we use omnext. There's this thing you can do where you use macros to define your React components. And there are these special components, I'm calling them S1 and S2 here, that let you switch in the UI amongst alternatives, right? They're known as unions. Or actually, in omnext, the union is part of the query, but close enough. So the idea is when I first start the app, one of these things is in view. So that's the green stuff. The green stuff is the stuff that's going to be available as the thing starts. And at the switching nodes, A and Y here are alternative things that could eventually show up on the screen, but aren't currently in view. Now, the way things are structured, I can set up the initialization code so that all of the state that these things need end up in my application state during startup if they're in the green. But the blue ones aren't actively in the tree, and so I don't see them. So the algorithm that I'm trying to write here walks this graph, essentially, this tree really, and tries to find the unions and initialize the blue nodes. So that's it. And this is what it looks like. It's a fairly large piece of code. The first part is the search through the tree, and the yellow thing there is the only thing that matters. I care that this side-affecting thing happens for the blue nodes. Now, when you look at that, first of all, I would say that someday I might refactor that and break it up into pieces, but ultimately this is an abstraction that's just trying to make a very simple thing happen. Walk the tree, find the blue stuff, call merge on it. So if I try to test this with the bite the onion thing, what I end up doing is I have to initialize the entire application, get it going, and then invent, write the tree out, run it, and then go and look in the application database and check to see, all right, are those two things in there? Right? And the other way I could do that is I could write a test that looks like this. Oh, now we're back to the complicated groan-producing test. Right? What I'm doing here essentially is I'm using with redefs down here at the bottom to stub out merge state so I don't have to actually initialize the application. But then I'm having to keep track of what got called and what it got called with, and did something get called that wasn't supposed to be called, right? I don't want to reinitialize nodes that are already called. There's a lot of extra noise here. So I've got high noise, low signal. There's only 3 things I care about here, that when I call merge alternate union elements, it merges 2 things. So I've sort of dipped my onion rings in lime jello, right? By the way, it's really hard to come up with an idea about making onion rings not tasty. It's like chocolate pudding. That might be good. Lime jello, okay. They're like the Paula Deen pixie dust, right? You sprinkle them on anything, and it's just like, yeah, that's tasty. So this is what it looks like in untangled spec. So what we've added is a stubbing system that allows you to very concisely say, I'm going to stub out, that's what the when mocking thing is. And notice I'm using my words here. The specification for merge alternate union elements. I've got a little comment above showing an ASCII art graph telling me which nodes aren't present. When mocking merge state, it's going to be called one time, and it better be called with the state of A. And then it's going to be called another time. That's what the 1x is for. I can specify how many times it should be called. And on the left, I'm capturing the argument. So I get argument capture, I get order, I get the ability to assert on the right-hand side, and then I can actually return whatever I want to return from that right-hand side, and that'll be the real return from the stubbed thing. So it's sort of like a scripting system for the things that you don't actually want involved at the moment, right? And so this reads very clearly. I run the thing on R, and it should merge A and Y, and nothing else. And that's something that's implied here by the scripting system. If you read the documentation, it tells you that merge state, if it were called any more than this, the test would fail and tell me merge state was called more times than you said it should be called. And this happens all over the place in our programs. We have a lot of orchestration code, right? These are all the middle layers, right? They're talking between layers. They're saying, all right, when I do daily processing, well, okay, when it's Tuesday, I want to start weekly billing. Well, how do I test that? All right, well, I could set the system time to Tuesday, and I could start up the database, and I could run the thing and see that it starts the billing. Ouch, right? That's really painful. It's really kind of expensive. And so very often what we do is just write it, we try it out once, and we just say now and forever that's good. But what happens when somebody comes in and messes with this function and is using par infer, and they hit space and indent it, and the parentheses change, and now it doesn't get called, or it gets called every day, right? We do want some protection for these kinds of things. And same sort of thing, right? I can say when day of week gets called, it returns Tuesday, and then start weekly billing gets called, and I don't care what it returns. I'm basically using that to assert that it does get called, and the test will fail if it doesn't. And then I call daily processing. This is low cost. It tells me exactly what I'm asking for, and gives me the result I'm looking for. But this is not without problems. And those of you who have done much testing hopefully already see the problems with this. The 2 big issues with this are, am I fooling myself? Right? I just said day of the week returns Tuesday. If I was doing this test driven, right, well, maybe that returns 2. Maybe I didn't remember it right. Maybe I was thinking of some other function that uses keywords for the day of the week, and I happen to use a different one that returns numbers. Well, now my test is going to pass, but my program's broken. Right? So this is kind of a problem. The other issue is I always have the potential, because I'm partially mocking here, and those who've played with testing for a while know what I mean by that, but essentially think about this code. What happens to this code if you're doing programming well? Well, you don't really change it unless the specification really changes, but you might add things to it. There may be a new thing you need to do in daily processing. That's a perfectly valid thing. And daily processing is a side-affecting sort of thing that might talk across networks, might decide to talk to a new database, might talk to a job scheduling system. When I add something to this, and now I rerun this test, that side-effecty thing that I haven't stubbed out happens. And my test hangs or chokes or crashes for a bad reason. So that's a thing that is a second problem here. So those are the 2 main problems with this sort of testing. And I want to point those out because they're both addressable. So the first is addressable with clojure.spec. And in fact, untangled spec includes this in its mocking checks. If there's a spec for the function, it verifies it. So I kind of think of this as the bloomin' onion. of our onion rings, right? Let's tie the onion rings back together so that we have some faith that we have at least connected them correctly, right? I'm not saying this thing connects to that thing and pretending it's one way when in fact it's another. So that's one way of solving the first problem. The second problem is a little more challenging, but essentially it boils down to having some way of either auto-stubbing the things that you've not said anything about or asking for explicits there. Now, if you're doing tests around these functions, that's not really that bad of a result. If you think about it, if you really are covering the thing with tests, as you add behaviors, you should be adding tests. I don't care if you're driving it or not. And when you do that, you can go back and fix things up. So it's not perfect, but it is low cost and it does give you kind of high value for that cost. So I'm going to do one more example. It's a kind of a real example in the wild. I went and dug through Clojure Core and I found this. This is the instance method. And I've stripped out there's a big doc string, or there's a bunch of metadata that was here that I stripped out for simplicity. And in this case, I've got a native JVM call. And I don't care what mocking system you use, you can't mock that out, right? You're stuck with it. That's a low-level call to a C function that's written in the JVM. Now, I do trust that the JVM works, because if it doesn't work, all bets are off, right? Once you go outside of your onion to the context that your onion is hanging out in, you're not responsible for that stuff working, right? That's supposed to be tested by others. And the existing unit tests for this look like this. And this is a common problem in open source software in general. I have the same problem with the open source projects that I work with, is you take contributions, people give you tests, and you're like, all right, well, it covers the thing sort of, and good enough, I'll keep it. But what's wrong with this test? I mean, technically there's nothing wrong with it in the sense that it runs and passes and does tell me something, but do I really, when I say test instance, am I meaning to test that 1 + 2 is a long? Is that, I mean, is math something I'm trying to test here? No. Is the result of the plus operator something I'm trying to test here? No, right? So there's a lot of noise here. I'm really kind of confusing the reader. I've said I'm testing instance, but what I'm really testing is that some of the built-in types come back as the right types. And I'm sort of getting instance by inference, right? That's what I'm getting. So what about this? I could say instance is a pass-through call to the JVM class isInstance method. I could read the source code. I've got metadata that points to it. I could find it, pull it in, and then just compare. All right, well, at least this test is very tight. It proves exactly what I'm saying about isInstance. It's just a pass-through call. It's a pretty name for something that already exists. But I don't know, it's not terribly expensive, but it's also not super cheap. So, you know, I might choose to do something like this, might choose to do something like this. If inference is enough, right, the original test I saw, well, then why not just say that? Again, use my words. Instance is a pass-through call to the JVM instance method that I'm inferring by testing against string. How long did that take me to write? It took me longer to write the sentence explaining it than it did to write the test. It shouldn't fail for bad reasons. It does state the assumptions. It's got a clear label. You can be the judge, and perhaps when you judge this, you maybe think, do I really need a test for that? I don't know. We've got programming languages now that have, I mean, they continually improve our power. They give us tighter abstractions, less minutia to deal with. It is easier just to get stuff right. You know, having no test is a valid answer. If I look at instance and I say, you know what, if instance breaks, all this other stuff's going to break. Do I really need to even waste the 10 seconds writing the instance test? That's a valid argument. So, you know, I'm not one of those zealots that says you must test and cover everything. Use your brain, right? It might already be covered. Now, it is a programming language, so you might argue the other way. Well, it's a programming language. I want to make sure all of my constructs have some coverage. Again, you're the judge, and you're also the person spending your time and money. So I just encourage you to keep that to a minimum. And then, you know, it's now a loose bag of working parts. Do we put that in our Santa sack, shake it up, and get working software? No, we don't. It often does work. I've gotten really good results out of this. I've built, you know, pretty large modules for software systems with these techniques. and released them to the wild or run them and played with them and found no problems whatsoever. And then when released to the wild, what I get back is, it doesn't do this right. And we go and look, and we actually specified it wrong. We actually said it should do A, and really the users want it to do B. All right, you can't avoid that. That's going to happen. And you also have, you run into things like concurrency and all sorts of other fun things. You can't really test those in this way. So again, it's not a panacea, but for a lot of web app development and business software, this does get you good results. So I'm essentially advocating, turn your time of fiddling with it into something a little more productive and reusable, a little more leverage. And I'll say one final thing about testing and design, because this is one of those things where, do my tests help my design? And designs really should come first, but good designs are generally easy to test. And so what I've found is, when you use your words, when you enumerate the things that a thing is supposed to do in detail, where somebody can come behind you a week later and read it and know what you meant, it means you were really thinking about it. It encourages you to spend more hammock time, less time typing, well, I mean more time typing English, but less time coding, more time thinking about what it should actually do. That's always a good thing. And the other thing is, I've really found that if you're writing a test and you're going, oh my God, this is so hard to test, it probably means your design is bad. You haven't decoupled something. You haven't decomplected it, right? You haven't made it simple. And by the way, the cake is a lie.